Welcome to The Explainer. Today, we're going to pull back the curtain on a tool that works silently behind the scenes. It's kind of like a digital butler, and it's the secret sauce behind how so many of your favorite apps get built and updated. Its name? Jenkins. You know that feeling, right? You tap update on your phone, and just moments later, you've got brand new features. It almost feels like magic. But it's not magic, it's automation. And for a huge number of development teams out there, the very heart of that automation is a tool called Jenkins. So, to really get why Jenkins is such a big deal, we kind of have to rewind a bit. We need to understand that the pain it was designed to fix. So, let's take a look at what building software was like in the old way, before this kind of automation was even a thing. Honestly, not that long ago, releasing software was this super slow manual process, just full of headaches. You had developers writing code, and then they'd basically just throw it over the wall to an operations team to deal with. It created huge bottlenecks, opened the door for all sorts of human errors, and it meant updates were rare and really risky. It got to a point where everyone realized, okay, we desperately need a better way to do this. And that need for change brings us right to the hero of our story, Jenkins. The best way to think about it is as this central automation server. Yeah, a digital butler or maybe a factory foreman that just steps in and manages the whole process from start to finish. So what is it exactly? Well, at its core, Jenkins is an open source automation server. Its whole job is to take the code that developers write and just automatically handle the entire process of building it, testing it for bugs, and then getting it all packed up and ready for release. You could say it's the engine that powers the modern software factory. So why did it get so incredibly popular? Well, it really comes down to a few key things. First off, it's free and open source. That's huge. It removes any cost barrier right off the bat. Second, it's ridiculously flexible. The core of Jenkins is pretty simple, but its real power comes from thousands of plugins that let it connect to almost any other tool you can imagine. And finally, it's backed by this massive global community, which means it's super reliable and always evolving. Now, Jenkins doesn't just automate things randomly. It's actually built to enable this really powerful and structured way of making software, and it's known by an acronym, CI/CD. So let's actually break down what that means. Okay, the first part is CI, which stands for continuous integration. The big idea here is simple but powerful. Every single time a developer makes a change, no matter how small, that new code is automatically merged in with everyone else's, built, and then tested. This is a game changer because it catches bugs super early before they spiral into these massive hard-to-fix problems. And the second part is CD. Now, this can mean one of two things, continuous delivery or continuous deployment. The goal for both is exactly the same, get the fully tested code out into the world. The only difference is that final step. With continuous delivery, the new software is ready to go live with just a push of a button. But with continuous deployment, it takes it one step further and releases automatically, no humans required. So, what does this whole CI/CD process actually look like when Jenkins is running the show? Let's walk through a typical automated workflow, which in the biz is called a pipeline, to really see how this brings an idea from code to reality. Right, so the best way to picture it is as a digital assembly line. It all kicks off when a developer commits some new code. Jenkins sees that change and bam, it gets to work. It builds the code, runs a whole bunch of automated tests, and if everything looks good, it packages it all up and gets it ready for deployment. The key here is that each stage is like a quality checkpoint. If any single step fails, the whole pipeline stops right there. And this really helps demystify what Jenkins is doing under the hood. It's not some kind of magic. It's literally just running commands that a developer would normally have to type out by hand. For instance, this command right here, MVN clean package. It just tells a popular tool called Maven to compile a Java application. Simple as that. And here's another great example. This command tells Jenkins to use Docker to wrap the application up inside a container. And why is that cool? Because it makes the final product totally portable and easy to run on any server anywhere. That's a huge win for reliability and consistency. But you see, the power of Jenkins doesn't just stop with running one single pipeline. No way. Its real strength is in this massive, scalable ecosystem that makes it a perfect fit for pretty much any project you can throw at it. So if you look at the whole ecosystem, you can really break it down into four main pieces. Yeah, you've got the core automation engine at the center, but the real magic, the part that gives it superpowers, is that huge library of plugins. To handle really big projects, Jenkins uses things called agents. These are basically worker computers that let it scale up and run tons of jobs at the same time. And then, wrapping it all together is that amazing open source community, which is constantly providing support in new ideas. When you boil it all down, Jenkins is the backbone of modern software delivery. It creates this automated, reliable, and super fast path that takes an idea from a developer's keyboard all the way to you, the end user. It's an engine built for speed, quality, and collaboration. By taking what used to be this manual, error-prone craft and turning it into a high-speed, automated factory, Jenkins has totally changed the game for how we create software. It really makes you wonder, doesn't it? What other complex, human-driven processes are next in line for this kind of incredible automation revolution?